Now we discuss Pythagoras theorem applications and 2 marks questions also involving in that. It's very important notation, that is Pythagoras theorem. In the first video, just you write the notation, that is the statement ABC, angle B is equal to 90 degrees. Therefore, AC square is equal to AB square plus BC square. The square of the hypotenuse is equal to the sum of the squares of the remaining two sides. For this proof, just draw one perpendicular from a vertex B to the hypotenuse AC, that is D. By proving this Pythagoras theorem, if you use similar triangles, whenever a perpendicular drawn from the vertex to the opposite side, then the two triangles framed, these two triangles are similar. Whenever, always it is. A perpendicular line drawn from the vertex to the opposite side, that line divides the other two triangles are similar. Now, ABD and BCD are similar. As you take here, this is 90 degrees and this is theta and this is 90 minus theta. The sum of these three angles should be 180. Now it is also 90, it is theta, this is 90 minus theta and here this is theta. Because without writing this, we confuse which angle is a proportion by taking the sides. Here three notations we observe. First you take big triangle and with small triangle, and again big triangle with another small triangle CBD. Now these two triangles, one is ABD and second one is CBD. Now three cases we prove, also important in public examinations. Two triangles are in by using the Pythagoras theorem, and next one notation, that is BD square is equal to AD into DC. This is also one of the important notation. First you prove that Pythagoras theorem AC square is equal to AB square plus BC square. First you take in this small triangle and big triangle. In triangle ABC and triangle ADB, these two triangles, I take the big triangle and the small triangle. See the proportion here. In this small triangle, theta opposite side is BD by big triangle theta opposite side is BC. Theta is over. Now you take 90. Small triangle 90 opposite is AB. Big triangle 90 opposite AC. Now 90 also cover. Again 90 minus theta. In small triangle 90 minus theta opposite side is AD and big triangle 90 minus theta opposite side is AB. Now from these two, AB square is equal to, by cross multiplication, AC into AD. This is first equation. We find out AB square is equal to AC into AD by using this small triangle with big triangle, because both the triangles are similar. And if you take case 2, now again you take the big triangle ABC and small triangle CDB. In triangle ABC and triangle CDB. Again, by taking the first notation, same take for second triangle also. In the small triangle CDB, 90 opposite is BC. Big triangle 90 opposite is AC. Clearly observe that. In small triangle, theta opposite is CD. Big triangle theta opposite is BC. Now 90 minus theta. Small triangle 90 minus theta opposite side is BD. Big triangle 90 minus theta opposite side is AB. Now you take BC square here by cross multiplication these two. Finally we get BC square is equal to AC into CD, that is equation number 2. By taking small triangle to big triangle, we get AB square is equal to AC into AD. And small triangle CDB and big triangle ABC, we get BC square is equal to AC into CD. Now add 1 plus 2 here. 1 plus 2 here. AB square plus BC square is equal to, what about AB square? AC into AD plus AC into CD. Now you take AC common, AD plus CD. Now AC into AD plus CD, total length is AC. Now AC into AC, AC square. Therefore AC square is equal to AB square plus BC square. This is the Pythagoras theorem proof. The square of the hypotenuse is equal to the sum of the squares of its corresponding sides, that means other two sides. This is AC square is equal to AB square plus BC square. We have to prove it like this. We who segregate theta, 90 minus theta and theta, just opposite sides we have to observe in this particular triangles. It is easy to get AC square is equal to AB square plus BC square. Now these two notations are completed, and the third notation from this third notation, this is also very important for public examination. Third notation, that means third one, BD square is equal to AD into CD. Very important. If you take these two small triangles, we get this notation. Then the first one, AB square is equal to AC into AD. Second one, BC square is equal to AC into CD. And if you take these two small triangles, BD square is equal to AD into CD. The same notation we apply here. Now BD is the perpendicular line. Now these two triangles are similar in ADB comma CDB, right angle triangles. Just again you have to take 90 opposite. Here 90 opposite angle is AB by, in this triangle 90 opposite is BC. Now again from this triangle theta opposite is BD. In this triangle theta opposite is CD. Now 90 minus theta in this triangle opposite is AD, and here 90 minus theta opposite is BD. Now from these two, by cross multiplication, BD square is equal to AD into CD. This is also very important. A perpendicular line drawn from the vertex to the hypotenuse, the square of the perpendicular is equal to the product of AD into CD. That means hypotenuse, product of AD into CD. In the public examination, BD is given or AD and CD is given. You have to find out BD by using this notation. BD square is equal to AD into CD. From this Pythagoras theorem, 3 cases we have to prove. First 2 cases for the proof of Pythagoras theorem, and third case is very important. BD square is equal to AD into CD. Now we discuss about the applications of Pythagoras theorem. In the public examination, I think 2018, now this notation what we have to prove now, that is BD square is equal to AD into CD, then prove that angle B is 90 degrees. This is reverse case actually. In right angle triangle, angle B is equal to 90, show that BD square is equal to AD into CD, that is the main problem. Now in the examination they give the reverse notation. If BD square is equal to AD into CD, now prove that angle B is equal to 90. ఇక్కడ కూడా మనం ఇలా చేసినట్టుగానే చేయాలి. రైట్ యాంగిల్ ట్రయాంగిల్స్ అప్లై చేసుకోండి. లేదు నాకు ఈ డయాగ్రామ్ ఇబ్బందిగా ఉందనుకుంటే మీరు ఇట్లా కూడా రాసుకోవచ్చు. మీరు నోటేషన్ మీరు ఏడి పర్పెండిక్యులర్ టు బీసీ తీసుకున్నా కూడా, అంటే ఒక్కొక్క డయాగ్రామ్ బట్టి మన యొక్క మైండ్ కూడా మారుతుంది జామెట్రీలో. మీరు ఇలా కూడా రాసుకునే పని అయితే ఇంకా ఈజీగా వస్తుంది. హియర్ ఏబిసి ఇస్ ఎ ట్రయాంగిల్, ఏడి పర్పెండిక్యులర్ టు బీసీ, ఏదైనా పర్లేదు. అప్పుడు ఏమవుతుంది మీకు, ఏడి స్క్వేర్ ఇస్ ఈక్వల్ టు బీడీ ఇంటూ డీసీ అవుతుంది. ఎట్లయినా పర్లేదు, దేని మీదకైతే మనం పర్పెండిక్యులర్ గీస్తున్నామో దాని యొక్క నోటేషన్ అప్లై చేసుకోవచ్చు. ఇప్పుడు దీని ప్రకారం మనకి ప్రాబ్లం ఏమవుతుంది, మనం డయాగ్రామ్ మార్చాం కాబట్టి నౌ ద పర్పెండిక్యులర్ లైన్ డ్రాన్ ఫ్రమ్ ద వర్టెక్స్ ఏ, దేర్ఫోర్ ఏడి స్క్వేర్ ఇస్ ఈక్వల్ టు బీడీ ఇంటూ డీసీ. దట్ మీన్స్ యాంగిల్ ఏ 90 అని ప్రూవ్ చేయాలి మనం. ఇట్స్ ఆల్సో వెరీ ఇంపార్టెంట్. దీనికి ఎలా ప్రూవ్ చేస్తాం మనం, ఇది 90 కాబట్టి 90కి అపోజిట్లో ఏబీ స్క్వేర్ ఉంది కాబట్టి ఏబీ స్క్వేర్ ప్లస్ బీడీ స్క్వేర్ ఈజ్ ఈక్వల్ టు ఏడీ స్క్వేర్, దట్ ఈస్ పైథాగరస్ థియరమ్. అండ్ ఆల్సో a line drawn perpendicular to the opposite side means these two triangles are similar. These two triangles are similar. This is 90 means the sum of these two angles also 90, and this is 90 means these two angles also 90, because 90 plus 90 180 in a triangle. Now I take from triangle ABD angle D 90, therefore sum of these two angles, angle BAD plus angle ABD is equal to 90 degrees, because these two angles sum is 90, this triangle sum of three angles is equal to 180. From this also this is 90, and angle CAD plus angle ACD is equal to 90 degrees. Because in any triangle sum of three angles 90, by taking these two we get 90 and 90. And by observing this, these two angles are corresponding angles, and these two angles also corresponding angles. By taking these two angles just in the place of ABD, in the place of, that is BAD plus ABD, in the place of ABD we have to write DAC, then sum of these two angles are equal. Since angle ABD is equal to angle DAC and angle BAD is equal to angle ACD, తెలుగులో అనురూప కోణాలు అని అంటారు. corresponding angles, because both the triangles are similar. Then in the place of ABD we have to write DAC. Now angle BAD plus, in the place of ABD you write DAC is equal to 90 degrees. This is angle BAC is equal to 90. Angle BAC is equal to 90 degrees. Angle BAC in the sense angle A is equal to 90. This is a right angle triangle. Whenever a perpendicular line from the vertex to the opposite, that means AD square is equal to BD into DC, then the opposite angle should be 90 degrees. Okay, this is one of the notation and one of the important public bit also, 2 marks questions also. And again second notation is in a right angle triangle AD perpendicular to BC, then show that AB square plus CD square is equal to BD square plus AC square. This is also one of the notation. In a right angle triangle, AD perpendicular to BC, if you take just AD perpendicular to BC, then AB square plus CD square is equal to BD square plus AC square. Is also very easy by using a right angle triangle. Just this is right angle triangle, angle D 90, and this is opposite side. By applying Pythagoras theorem here, I want AD square. First we apply Pythagoras theorem. AB square is equal to BD square plus AD square. I want AD square. AD square is equal to AB square minus BD square. That is equation number 1. From this here also 90 is there. We apply Pythagoras theorem here. AC square is equal to AD square plus CD square. Now I want again AD square. AD square is equal to AC square minus CD square. This is equation number 2. See, in the first one AD square and second one also AD square. Now AD square, ADs are equal. Now by equalizing these two RHS, AB square minus BD square is equal to AC square minus CD square. By taking CD square here, AB square plus CD square is equal to AC square plus BD square. This is important notation by using the Pythagoras theorem. In a right angle triangle, AD perpendicular to BC, there is no right angle here. AD perpendicular to BC, AB square plus CD square is equal to BD square plus AC square. Just we have to note down the Pythagoras theorem and find out AD square, because AD is common from these two triangles, similar triangles. Therefore, AD square is equal to AB square minus BD square, and AD square is equal to AC square minus CD square. Common AD square RHS are equal, then LHS are equal, then we get AB square plus AD square is equal to AC square plus BD square. This is also an important notation from the Pythagoras theorem. ఇవన్నీ డూ దిస్ ట్రై దిస్లో ఉంటాయండి, మీకు కష్టం అని చెప్తున్నాను. కంపల్సరీగా ఎగ్జామినేషన్స్కి డూ దిస్ ట్రై దిస్ కూడా వస్తాయి. నెక్స్ట్ Pythagoras theorem application, very important. That is, in a rhombus, the sum of the squares of the sides is equal to the sum of the squares of its diagonals. It's very important notation. In a rhombus, the sum of the sides AB square plus BC square plus CD square plus DA square. The sum of the sides of a rhombus is equal to the sum of the squares of its diagonals. Is also a very important question in the Pythagoras application part. For this, just you draw a rhombus here. That is ABCD is a rhombus. Join AC and join BD. The intersecting point is O. Now this is all right angles, because in a rhombus the diagonals are bisecting at right angles. Then you get 4 right angle triangles here. What you have to want? The sum of the squares of the sides is equal to the sum of the squares of its diagonals. Just we show that in a rhombus the diagonals are bisecting each other. For this proof, just we have to note down this important point. The diagonals are bisecting each other in the sense AO is equal to OC is equal to AC by 2. In the same way, OB is equal to OD is equal to BD by 2. These two are the important notations to get this property. AB square plus BC square plus CD square plus DA square is equal to AC square plus BD square. For this, just you know that 4 right angle triangles. You take first triangle by applying a Pythagoras theorem. AD square is equal to OA square plus OD square. From this triangle, hypotenuse square is equal to side square plus side square. Similarly, AB square is equal to OA square plus OB square, and similarly BC square is equal to OB square plus OC square, and similarly CD square is equal to OC square plus OD square. Now these four applications by using Pythagoras theorem from this diagram, just you take it as 1, 2, 3, 4. By adding 1 plus 2 plus 3 plus 4, we get the original what you have to prove it. AB square, B square, CD square, A square is equal to AC square plus BD square by using this property. AO is equal to OC is equal to AC by 2. Now add 1 plus 2 plus 3 plus 4. Okay. Now adding 1 plus 2 plus 3 plus 4. Just to add, we get the theorem. That is equal to AB square plus BC square plus CD square plus DA square is equal to 2 times OA square, 2 times OB square, 2 times OC square and 2 times OD square. Now you take 2 common here, OA square plus OB square plus OC square plus OD square. Now we know that OA is equal to starting AC by 2. AC by 2 means AC square by 4. OB is equal to BD by 2, BD square by 4. Again OC is equal to AC by 2 and OD is equal to BD by 2. By squaring on both sides, we get AC square by 4 plus BD square by 4 plus AC square by 4 plus BD square by 4. Now here AC square plus AC square again 2AC square by 4, that means AC square by 2, BD square plus BD square 2BD square by 4, that means BD square by 2. Now taking a LCM, AC square plus BD square by 2, now 2 to cancel, we get AC square plus BD square. Now our notation is the sum of the squares of the sides is equal to the sum of the squares of its diagonals. It's very important 2 marks question. Just by using OA is equal to OB is equal to AC by 2, BD by 2 concept. Now one important property, similar property, just one problem, very important problem. We know that the similarity property, the last class we discussed about this area related similarity property. The area of, the ratio of the areas of two similar triangles is equal to the ratio of the squares of its corresponding sides. AB square by D square, BC square by EF square and AC square by DF square. From this, a small notation in the examination is very important. If you take 2 triangles, one is ABC and second similar triangle is DEF. If BC is equal to 3 and EF is equal to 4 and area of triangle ABC is equal to 54 cm square, find the area of DEF. Find the area of DEF. It's very important concept, important 2 marks question. We know one property, one is the ratio of the areas of two similar triangles is equal to the ratio of the squares of its corresponding sides. The same application here. Here BC is equal to 3, EF is equal to 4, area of ABC is 53. By applying the theorem, area of triangle ABC by area of triangle DEF is equal to, we know BCEF, therefore BC square by EF square, this is equal to 54 by area of triangle DEF is equal to BC 3 square and EF 4 square. That implies area of triangle DEF is equal to 16 into 54. 16 into 54 by 9, 96x, 96 cm square. This is also a very important notation, 2 marks. The ratio of the areas of two similar triangles is equal to the ratio of squares of its corresponding sides. When two sides are given, one area is given, you have to find out another area. Then sometimes two areas are given and one side is given, you have to find out the other side by using this property. This is also important 2 marks question. And examination also, I think in 2017 or 18, two triangles ratio is 25 by 36 is given. Just easy to, you have to find out the bit. The areas is equal to 25 by 36. Find the ratio of the sides. Find the ratio of the sides. It's very easy. Just square this side. Square root of 25 by 36 is equal to AB by DE. That is equal to sides ratio is equal to 5:6. These are the very simple concepts when bits are given and 1 mark is given by applying this property. Thank you. Already in similar triangles, 2 videos are completed. One is related to 1 mark questions and statements, and second video related to Pythagoras theorem and applications. Now the third video of similar triangles is Thales theorem and its application. Thales theorem. Already in the first video, we know the statement of BPT. What is the statement of BPT? If a line drawn parallel to one side of the triangle, that line divides other two sides in the same ratio. This is the theorem of BPT. Earlier we discussed in the first video. Now I have to prove that equation. That statement or theorem. Just you take one triangle, that is ABC, D, comma E are the 2 points on AB and AC. Join DE, we get a line. This line is parallel to the one side of the triangle, and this line that divides the other two sides in the same ratio. Therefore, proof is equal to, we have to prove AD by DB is equal to AE by EC. Divides other two sides in the same ratio. Just we have to prove this statement just by joining BE and CD, because we have to find the ratios, means we want triangles, and join again 2 points here. We take M comma N, whatever the points we have. Now we have to prove this one. Already we know the similarity procedure. Just area of AD by area of here BD. Two triangles are have to obtained by joining BE and CD. BE ni CD ni మనం జాయిన్ చేయటం వలన రెండు ట్రయాంగిల్స్ వచ్చినాయి ఇక్కడ. One is BDE, one triangle. Another one is CDE is another triangle. Now here one triangle is ADE. This is a final triangle. Just draw perpendiculars on AD and perpendiculars on AE. Now we have to prove this theorem. Just very simple, by taking one area AD, common area by different areas. That means area of triangle ADE by area of triangle BDE. Small triangles. We know area of triangle formula is half into base into height. Now in ADE, base is equal to, here perpendicular drawn from E to AD. AD is the base and ME is the height. For half into AD into ME by, here area BDE area. Here there is no base because there is no perpendicular here. That's why extended D to M and join EM. This is the perpendicular of BDE. Now the base is BDE and height is also again ME, because this is an obtuse angle triangle. In obtuse angle triangle, right angle is outside the triangle. That's why the height should be ME. Therefore half of cancel, ME cancel. We get AD by BD. This is equation number 1. By applying the same notation here, area of triangle AD by, now I have to take this triangle, area of CDE. Area of triangle CDE. Now I apply same notation half into here ADE area by using CDE triangle. Therefore, I have to take this right angle triangle drawn from D to AE. Therefore, height is now DN. Base is AE. Half into AE into DN by, again area of CDE. This is also a obtuse angle triangle. Therefore, there is no height here. Just you take here DN is the height of the triangle. Now C is the base and height is equal to DN. Therefore, half into C into DN. Now here half of DN cancel, should get AE by C. This is equation number 2. Now only the concept is obtuse angle triangles, the height should be outside of the triangle. Thus we have to write ME and DN. Now we obtain 1 and 2. We have to see these two, area of ADB, area of BDE, and area of ADE by area of CDE. Just to observe these two triangles, area of BDE and CDE lies on the same base DE and between the parallel lines DE and BC. This is one of the theorem, area theorem. Two triangles are on the same base and between the parallel lines, their areas are equal. Here, area of BD and area of CD lies on the same base DE and between the parallel lines DE and BC. Therefore, area of triangle BD is equal to, area of triangle BD is equal to area of triangle CD. This is very important notation. If both areas are equal, then the AD is equal and BD is BD equal and both are cancelled. Again you get 1 is equal to 2. Therefore AD by BD is equal to AE by CE. This is the BPT, basic proportionality theorem. You have to write the statement here. If BDE and CDE triangles are same base DE and between the parallel lines DE and BC, then their areas are equal. If these two areas are equal, automatically 1 is equal to 2. AD by BD is equal to AE by AC. Therefore, if a line drawn parallel to the one side of the triangle, that line divides the other two sides in the same ratio. This is the very important theorem, and we have to know the applications of Thales theorem. Important 1 mark and 2 marks, applications of Thales theorem. Now this is the first bit from March 2016. March 2016 లో వచ్చినటువంటి ప్రాబ్లం చూడండి. In the given figure ABC and D is 5, D is equal to 5 centimeters and here 3 centimeters and here 6 centimeters. Find the value of x. Here this is very important because whenever you have to know AD by DB is equal to AE by EC, but they have given D is equal to 5 and find the BC. Now I apply the same notation here, just two sides we apply. Now I have to apply this one. BC by D is equal to AE by EC. The same notation I apply here. By Thales theorem, just actually we know that AD by DB, but here side is DE by BC. Therefore, the longest side is BC here. BC by DE is equal to, here longest side is AC. This is also very important. If the problem is getting the answer, just this is the logic. AD by DB is equal to AE by EC is the Thales theorem. But here whenever DE is given, this is the big side. BC by DE is equal to take the big side by small side. This is very important. Or BC by DE 5 centimeters by AC means 6 plus 3, 9 by 3. Now here 3 cancel. BC is equal to 5 into 3, 15 centimeters. This is March 2016 problem. And again, one of the important problem. Here one diagram is given. This is March 2019. March 2019 లో వచ్చిన ప్రాబ్లం ఇది. Just one diagram is given. One diagram is given. This is 3 and this is 5 and this is 3 and this is 2.5 and this is 6. In what way these two triangles are similar? Very important. In what way? That means either angle side angle or angle or side like that. In what way these two triangles are similar? Just we have to write a side by side because similar in the means two triangles are similar. Two triangles are similar. That means side by side 3 by 6 is equal to side by side 2.5 by 5. Now here 1 by 2 is equal to 1 by 2. Corresponding sides are proportional. Therefore by side angle side, because these two are vertically opposite angles, side angle side theorem, the area of triangle ABC is equal to area of triangle. Is like write ABC or here D you have to take BDE are similar. By which SAS. This is very important. In that 1 mark will be given and these two are the proportional concept. Because when two sides are proportional, definitely side angle side, thus two triangles are similar. It is also very important. We know the straight way, but in the examination they are giving in from back end to first side. Now another one. See, all squares are similar. This is June 2019. Justify your answer. Yes, all squares are similar. In the first video, I have to discuss like that. All squares are similar. And March 2018, in triangle ABC, this is by application of Thales theorem. In triangle ABC, this is March 2018 problem. Here PQ is given. This is x minus 5, that is PB, and here only 3, and AQ is equal to x minus 3, and this is 3x minus 19. Find the value of x by using this diagram where PQ parallel to BC. Very easy. PQ parallel to BC in the sense this is the BPD theorem. Now the sides are proportional. That means by AP by PB is equal to AQ by QC. Therefore 3x minus 19 by x minus 5 is equal to x minus 3 by 3. By cross multiplication 9x minus 57 is equal to x square minus 8x plus 15. Now x square minus 8x minus 9x plus 15 plus 57 is equal to 0. For x square minus 8 plus 9, 17x plus 72 is equal to 0. I have to take factorization here. 9 into 8, 9x minus 8x plus 72 is equal to 0. For x minus 9 into x minus 8 is equal to 0. For x is equal to 9 and x is equal to 8. Just by using the variables x minus 5, 3x minus, just to apply the formula and get the answer. And in this one important question is also there. That is same way you have to discuss in June 15 also, the same type will be given. And the same models we have to apply. And from this, one trapezium problem also given. One trapezium problem also very important. If ABCD is a trapezium, number of times this question also comes in the examination. If ABCD is a trapezium, and join here AC and BD, intersect at O, show that AO by OC is equal to BO by OD. It's very important notation. If ABCD is a trapezium, show that AO by OC is equal to OB by OD. And just we have to take this is given, and to prove, already we know that to prove AO by OC is equal to BO by OD. Just from this here, by applying Thales theorem, just you draw a parallel line to the base. This is the final notation, because we apply BPT only the parallel. Just here by construction joining here one line, that is P comma Q, passing through the point O. Now we get two triangles. And the OP is parallel to AB. See that OP is parallel to AB and same OP is parallel to CD. Just we apply BPT, we get the answer. First I take OP parallel to AB by taking the triangle ADB. In triangle ADB, OP is parallel to AB. A line drawn parallel to one side, that line divides other two sides in the same ratio. Therefore, by BPT, this line divides other two sides, means AP by PD is equal to OB by OD. That is equation number 1. Now the same way here, OP is parallel to CD also. Again we apply by taking BPT here. By BPT, again AP by PD is equal to, by taking this triangle, AO by OC. Equation number 2. This is OP parallel to CD. OP is parallel to AB, one notation. OP parallel to CD, one notation. Therefore, from 1 and 2 here, AP by PD, LHS sides are equal. Therefore, RH sides are equal. Therefore, from 1 and 2, OA by OC is equal to OB by OD. This is very important 2 marks question. The same way they are given, if OA by OC is equal to OB by OD, then show that ABCD is a trapezium. Very simple. You come back again, you get the answer. Now this question is, if ABCD is a trapezium, diagonals are intersected at the point O, then show that AO by OC is equal to OB by OD. Just by using BPT, we get this notation, OA by OC is equal to OB by OD. Sometimes here values are given, these 3 values are given, you have to find this one by using trapezium. Just to apply this notation, we get the answer. These type of questions by using BPT, and one question also given, that is a essay question like this here. Here 3 lines are parallel. Just by using this, joining this, here X, Y, Z they are given. Just by applying BPT, we get the answer. Just applying BPT, we get the answer. Very easy here. Just you take these 2 parallel lines of this triangle, 1 by Y, 1 by X, 1 by Z, like that, we get the answer. One problem also this is there, that is 1 by X plus 1 by Y is equal to 1 by Z. 1 by X plus 1 by Y is equal to 1 by Z. This is one of the essay questions that will explain by in essays video, 6 marks video. Now this is related to BPT theorem. And again BPT also, the statement is very important, and also converse is also very important. And simple problems are there in your textbook. That is in the first exercise. Very simple problems are there. That also you can do. And mainly examination point of view, I will explain here. If you want more, go through the textbook. And even converse of BPT also there. In converse of BPT, just if they want the proof of converse of BPT, it's very simple to explain. No need to very hurry. If you take ABC is a triangle, DE is parallel to BC, is explained through converse of tails. Converse of tails. Proof converse tails is very easy by using the contradiction, because there is no proof here, it's just contradiction. What about BPT? If a line divides other two, if a line divides one, if a line parallel to one side of the triangle, that line divides other two sides in the same ratio. Just by converse means, if a line divides other two sides in the same ratio, that line is parallel to the third side. Now here D is parallel to BC. Now here D is parallel to BC. Now I draw another line here which is not parallel to BC. You have to take F here. F here on AC. Now in my assuming DF is parallel to BC. My assuming, because this is contradiction method. Suppose if you take DE is parallel, AD by DB is equal to AE by EC. Now you take F here. DF is parallel to BC. Now AD by DB is equal to AF by FC. In my sense, DF is parallel to BC. If D is parallel to BC, AD by DB is equal to AE by EC. Now here if DF is parallel to BC, AD by DB is equal to AF by FC. From 1 and 2 here, AD by DB is equal. Therefore, AE by EC is equal to AF by FC. AE by EC is equal to AF by FC. Just adding 1 on both sides. Add 1 on both sides. As AE by EC plus 1, that is equal to AF by FC plus 1. For AE plus EC by EC is equal to AF plus FC by FC. Now AE plus EC. AE plus EC means AC we get. That implies AC by EC is equal to AF plus FC also AC. AC by FC. Now here AC cancel, we get EC is equal to FC. See here from the figure, EC is equal to FC. EC length is very small than FC, but here EC is equal to FC. This is the contradiction, because EC is not equal to FC. ఎందుకు వచ్చింది ఈ కాంట్రడిక్షన్? ఇఫ్ యూ టేక్ డిఎఫ్ ఈజ్ ప్యారలల్ టు బీసీ, డిఎఫ్ అనేది బీసీకి ప్యారలల్గా ఉంది కాబట్టి మనకి అజంప్షన్ రాంగ్ వచ్చింది. బట్ ఇది తప్పు వచ్చింది కాబట్టి మనం ఏం చేయాలంటే డిఎఫ్ అనేది ప్యారలల్గా లేదు, ఓన్లీ డిఈ ఈజ్ ప్యారలల్ టు బీసీ అని మనం చెప్పగలము. దేర్ ఫోర్ యూ టేక్ ద అజంప్షన్ హియర్ ఈసీ ఈజ్ నాట్ ఈక్వల్ టు ఎఫ్సీ యాక్చువల్లీ. దేర్ ఫోర్ డిఎఫ్ ఈజ్ నాట్ ప్యారలల్ టు బీసీ. దిస్ ఈజ్ ద converse of Thales theorem. If a line divides other two sides in the same ratio, that line is parallel to the third side. Now here DF is not parallel to BC, we get the wrong answer. EC is equal to FC. Therefore definitely DF is not parallel to BC, DE parallel to BC. Finally we find out DE parallel to BC. This is the converse of Thales theorem. Sometimes this is also applicable in the examination point of view. Now today we will discuss in similar triangles essay questions. The first essay question is, if AB, CD, PQ, BD are perpendicular to the base BD, if AB is equal to X, CD is equal to Y, and PQ is equal to Z, then show that 1 by x plus 1 by y is equal to 1 by z. This is a very important question. By using similar triangles, we get the solution. First, you take these two triangles BDC and BQP. Clearly observe that in triangle BDC and triangle BQP. See, once you check it, BQC, one big triangle, and BQP is a small triangle. See, by observing these two, angle B is common, angle B is equal to angle B, that is common angle, and here both are 90 degrees. Angle Q is equal to angle D is equal to 90 degrees. By AA similarity, these two triangles are similar. When these two triangles are similar, we apply the conditions, that is, the sides are in proportional. This is the small side and this is the big side from this. Therefore, BQ by BD is equal to height by height. That is equal to PQ by CD. That should be Z by Y. It is equation number 1. The first take this big triangle and this small triangle by applying similarity property side by side by side by side. And by taking again this side in triangle ABD and triangle PQD and triangle PQD. Now from by taking this big triangle, this is small triangle and this is big triangle. In this triangle, angle D is common. That means angle D is equal to angle D common side, and here B is equal to Q, angle B is equal to angle Q is equal to 90 degrees. Again, by using the similarity property, side by side, here small side is QD, small side is QD, big side is BD. QD by BD is equal to height by height, that is equal to PQ by AB, that is equal to Z by X. This is equation number 2. Now by adding these two, that is 1 plus 2 BQ by BD plus QD by BD is equal to Z by Y plus Z by X. Now here by adding BD plus BD, numerators are equal, BQ plus QD by BD is equal to, by taking Z common here, 1 by Y plus 1 by X. Now from the figure BQ plus QD, BQ plus QD is total, it is equal to BD. For BD by BD is equal to Z into 1 by X plus 1 by Y. Now BD cancel, from Z take this side, 1 by Z is equal to 1 by X plus 1 by Y. This is very important notation. If three lines AB, PQ and CD are perpendicular to BD, if AB is equal to X, PQ is equal to Z and CD is equal to Y, then 1 by Z is equal to 1 by X plus 1 by Y. Sometimes the same figure is given, they are given X and Z, you have to find out Y by using this application. Any two variables they are given, you have to find out the third variable by using the notation 1 by X plus 1 by Y is equal to 1 by Z. This is one of the important essay question. And the second one is rectangle. Pythagoras theorem by using rectangle. The second essay question, ABCD is a rectangle O is any point here. O is any point interior of the rectangle. As to A, B, C, D is a rectangle. O is the any point on the interior. So that OA square plus OC square is equal to OB square plus OD square. If ABCD is a rectangle, ABCD is a rectangle, O is interior point on the rectangle. Now I have to show that OA square plus OC square is equal to OB square plus OD square. Here I don't know the right angle here, because in a rectangle here, this is the right angle triangle, all are right angles, but I didn't apply here. Just by taking the construction here, by joining EF passing through O, now here this is also a right angle and this is also a right angle. By using the Pythagoras theorem, we get the answer. First here, first right angle, this is second right angle, this is third right angle, and this is fourth right angle. From these four right angles, we apply Pythagoras theorem. After that, by adding these four, we get the correct answer. First I taking in right angle triangle, first I taking this one OEA. From this right angle triangle, this is the hypotenuse. For OA square is equal to OE square plus AE square. This is the first equation. And from this right angle triangle, the same way you have to apply. This is the hypotenuse. OB square is equal to OF square plus BF square. This is equation number 2. And this is the third right angle triangle. Here, this is right angle triangle. This is the hypotenuse. For OC square is equal to OF square plus CF square. That is equation number 3. And this is the fourth right angle triangle. Here, right angle E, then OD is the hypotenuse. OD square is equal to D square plus OE square. This is the fourth equation. Now, I want OS square plus OC square is equal to OB square plus OD square. Now, any two have to take here OS square plus OB square. Just 1 plus 2 here. OA square plus OB square is equal to, OA means what? OE square plus AE square. OB means what? OF square plus BF square. From these four, I want OB and OD. I want OB means OF square plus BF square. Here OF square is also there, but I want only BF square here. But BF, from this diagram, BF is equal to AE. Now in the place of AE, I wrote BF here. That is BF square. Because in this rectangle, opposite sides are equal. BF is equal to AE. In the place of AE, I wrote BF square. Now I want here OD square. OD square in the sense D square plus OE square. Here D square plus OE square. OE square already there here. Plus now I want D square. DE means here. But DA is equal to CF square here. Now here D is equal to CF. Now here I have to write here OE square plus DE square. Now from this OF square plus BF square. OF square plus BF square means OB square. And OE square plus DE square is equal to OD square. Now from this OA square plus OB square is equal to OC square is OC square plus OD square. Now here a small notation here. You have to take OC square means OF square plus CF square. Here CF is equal to DE and this is OF square plus DE square, then OC square. OC square plus OD square. Now this is also a very important essay question. If ABCD is a rectangle, O is the interior of the rectangle, then OA square plus OC square is equal to OB square plus OD square. This is also very, very important. And the third essay is also regarding right angle triangle. Angle B is a right angle here, ABC, and D is the perpendicular and AC. The distance is P. Now this is BC is equal to A degrees and AB is equal to C, and here B is, this is also small b. Now two notations we apply this right angle triangle. One is equal to PC is equal to AB, and third one is 1 by P square is equal to 1 by A square plus 1 by B square. Here the problem is ABC is a right angle triangle. Angle B is equal to 90 degrees. Here AB is equal to C, BC is equal to A, BD is equal to P, and here AC is equal to B. Now here, from here two right angle triangles we apply. One is equal to half into base into height, and one is equal to half into base into height. One is equal to half into PB and half into AC. From this, just we apply here area of right angle triangle ABC. Area of triangle ABC means ABC triangle area is equal to half into base into height. Now by using this right angle triangle, this is half into A into C, that is equal to half AC. This is equation number 1. And the same area, by using this right angle triangle, area of right angle triangle ABC, again half into base into height BD. Now here half into, now base is AC, AC is equal to B, now BD is equal to P. Now this is second equation. From 1 and 2, half AC is equal to half BP, half of cancel, for PB is equal to AC. PB is equal to AC, or P is equal to AC by B. P is equal to AC by B. This is the first notation from this right angle triangle. From this, we know that P is equal to AC by B. By squaring, P square is equal to A square C square by B square. I want 1 by P square, just reverse. 1 by P square is equal to B square by A square C square. Now here B square means this is right angle triangle. By using Pythagoras theorem, B square is equal to A square plus C square. A square plus C square. The square of the hypotenuse is equal to the sum of the squares of the other two sides. Therefore, B square is equal to A square plus C square by A square C square. Just by dividing A square by A square C square plus C square by A square C square, A square cancel, C square cancel. Therefore, 1 by A square plus 1 by C square. 1 by A square plus 1 by C square. This is very important notation. Actually in the textbook 1 by P square is equal to 1 by A square plus 1 by B square అని ఉంటుంది. ఎందుకంటే మనం ఇక్కడ అక్కడ C దగ్గర రైట్ యాంగిల్ తీసుకుని ఉంటారు, మనం ఇక్కడ B దగ్గర రైట్ యాంగిల్ తీసుకున్నాం కాబట్టి మనకి 1 by P square is equal to 1 by A square plus 1 by C square వచ్చింది. ఒకవేళ కనుక ఇక్కడ C తీసుకుని ఉంటే, C దగ్గర రైట్ యాంగిల్ తీసుకుంటే ఖచ్చితంగా మీకు 1 by P square is equal to 1 by A square plus 1 by B square అనేది వచ్చేది. ఏదైనప్పటికీ రైట్ యాంగిల్ ఏదైనా ప్రొసీజర్ మాత్రం ఇదే కాబట్టి ఒక్కొక్కసారి మనం రైట్ యాంగిల్ ట్రయాంగిల్ ఇచ్చి ఏసి ఇచ్చిన బి కనుక్కోమనొచ్చు, లేదా పి వాల్యూ కనుక్కోమనొచ్చు. పి వాల్యూ కనుక్కోవాలంటే మళ్ళీ మనం 1 by P square is equal to 1 by A square plus 1 by B square వేసుకున్నా వస్తుంది. మీరు ఏ వాల్యూ అప్లై చేసినా సరే రైట్ యాంగిల్ బట్టి ఇవి మారుతూ ఉంటాయి. నేను ఇక్కడ రైట్ యాంగిల్ బి తీసుకున్నాను కాబట్టి నాకు ఇక్కడ బి కనపడలేదు. నేను కనుక ఇక్కడ సి తీసుకుంటే నాకు సి కనపడదు, 1 by A square plus 1 by B square కనపడుతుంది. కాబట్టి మనం ఏం తీసుకున్నా సరే జాగ్రత్తగా మనం అప్లై చేసుకుంటే ఒరిజినల్ ప్రాబ్లం అయితే సి దగ్గర రైట్ యాంగిల్ 1 by P square is equal to 1 by A square plus B square. కన్ఫ్యూజ్ అవ్వద్దండి. నేను బి దగ్గర 90 తీసుకున్నాను అంతే. సి దగ్గర 90 తీసుకుంటే ఖచ్చితంగా మీ టెక్స్ట్ బుక్లో ఉన్న ఆన్సర్ 1 by P square is equal to 1 by A square plus 1 by B square వస్తుంది. ఓకేనండి, దిస్ ఈజ్ ఆల్సో వెరీ ఇంపార్టెంట్. And fourth essay will be there, that is 9AD square is equal to 7AB square. Rarely the problem is given. Sometimes the paper is difficult, that problem is given. Otherwise 50-50 chances. In triangle ABC, D is the any point on BC. D is the any point on BC, and AE is the construction here. D is the any point on BC, and given BD is equal to 1 by 3 BC. Important condition. BD is equal to 1 by 3 BC. Now as usual, this is ABC. ABC is an equilateral triangle. ABC is an equilateral triangle. Equilateral triangle means all sides are equal. AB is equal to BC is equal to AC. ABC is an equilateral triangle, and here E is the midpoint and D is any point on BC. Now here E is the midpoint because ABC is an equilateral triangle. For A is the midpoint means BE is equal to half BC. BA is equal to BCలో హాఫ్ ఉంటుంది, ఎందుకంటే ఈ అనేది మధ్య బిందువు కాబట్టి సమాన దూరంలో ఉంటుంది. Now we want the main agenda is 9AD square is equal to 7AB square. This is the proof. The problem is, if ABC is an equilateral triangle, then D is the any point on BC, then you have to show that 9AD square is equal to 7AB square. But here we draw from the vertex A to BC, it is an equilateral triangle. Then if you draw from vertex A to AE, then E is the midpoint of BC. Therefore BE is equal to EC. In the same way, BE is equal to BC by 2. By using these three conditions, we get this answer: 9AD square is equal to 7AB square. From this, first I taken the small triangle here. From right angle triangle AED. From right angle triangle AED, we apply Pythagoras theorem. AD square is equal to DE square plus AE square. Is equation number 1. From this right angle triangle, AD square is equal to DE square plus AE square. Now first we find out DE and AE. After that we can AD square, we apply the answers, we get the answer. Now I want DE square, I want AE square. First I want to find out here AE square from this triangle. From right angle triangle AEC, నేను ఈ రైట్ యాంగిల్ ట్రయాంగిల్ తీసుకుంటున్నాను. దిస్ ఈజ్ రైట్ యాంగిల్ ట్రయాంగిల్, and AC square is equal to AE square plus EC square. AE square plus EC square. Now I want AE. AE square is equal to AC square minus EC square. AC square minus EC square. Here AC means this is an equilateral triangle. AC is equal to AB. We know that. In the place of AC we write AB square. And EC means half BC, because E is the midpoint of BC. EC is equal to half into BC square. EC means half BC square. Therefore AB square minus half into BC means again I have to take AB, because total problem is in AB square. Total problem is in AB square. Since here AB is equal to BC is equal to CA, because given triangle is equilateral. Therefore 4AB square minus B square, 3AB square by 4. This is equation number 2. I want to find AE square first. From this triangle I have to find AE square is equal to 3AB square by 4. Now I want DE square here. DE. Find here DE value. DE, how to find DE? The total BE minus BD. The total BE minus BD. What is BE here? You have to write here. BE is equal to half BC. Half BC because this is midpoint. And BD. BD value already given in the problem. That is 1 by 3 BC. Now here, by taking LCM BC, LCM 3, 2, 3, LCM 6, 3 BC minus 2 BC, that is equal to BC by 6. BC by 6. Now this convert BC into AB by 6 because we want AB square here. For this is number 3. Now we find out AE square is equal to 3AB square by 4 and here DE is equal to AB by 6. I want DE square. DE square means AB square by 36 వస్తుంది. AB square by 36 వస్తుంది. Just I remove this total part, above part. Just from the equation 1, we know that AD square is equal to DE square plus AE square. Now what is D here? What is D here? AB by 6. But we want D square. D square in the sense AB square by 36 plus what is AE square? AE square is equal to 3AB square by 4. Now I have to take LCM here, that is 36. 36 means that is AB square plus 4 into 9. 9 into 3, 27 AB square. Now 27 plus 1, 28 AB square by 36. 4 into 7, 4 into 9. Therefore, by cross multiplication, we get 9 AD square is equal to 7 AB square. This is also very important in competitive exams also. If ABC are equilateral, then AD is given, find out AB. Just to apply 9 AD square is equal to 7 AB square. Sometimes they are given what is the ratio of AD square and AB square? 7:9. ఇక్కడే ఉంటుందండి ఆన్సర్ అంతా. మనం ఈ మూడిట్లో ఏది ఇచ్చినా కూడా మూడోదాన్ని మనం కనుక్కోవచ్చు. అంటే these 4 are the important essays along with construction. Along with construction. Constructions also you know that your teachers are explaining clearly that the steps of construction are very important. Here 2 problems are there. One is improper and proper. By using proper and improper, first one is rough diagram is very important. After that main diagram, next steps of construction, after that proof. These 4 points are very clear in construction. So along with these 4 problems, construction is very important, highly important construction. I think out of 100%, 80% construction is very important and remaining 20% out of these 4 problems, any one of these, once using this Thales theorem and the rest of them all Pythagoras theorem we apply. Therefore, practice more in similar triangles. There is no confusion. Part wise we have to practice. In the first video I given the 1 mark. In second video Pythagoras theorem applications. Third video BPT applications. And fourth one is SAS plus constructions. Therefore, this type of planning will be there. Similar triangles are very easy. And also, if any doubt you have, please share in that group. I will explain the problems and post the problems. Thank you very much.